and it does give us some instructions here. Change these into improper fractions and then operate. And yeah, we do not want our answers as mixed numbers. We do not want that. Okay, so I'm going to go in here, and the first thing I'm going to do is change these two fractions into their improper fraction form. Now that's not going to change the operation. It's not going to change the two denominators, so I'm going to just push those in right there, okay? So I got fourths and thirds, fourths in the first denominator, thirds in the second denominator. And then I will apply cycle method to both, okay? So I'll do this first one in red. That would be 5 times 4, which is 20. And then adding the 3 numerator would be 23. Okay, so that gives us a new numerator of 23 fourths. And then the second fraction, once again, cycle method. So that's 3 times 3 rather, which is 9, and then add the 2 numerator, which is 11. So that is my new numerator for the second fraction. Now again, these are looking a little different because of the numerators, but the values have not changed. 5 and 3/4 is the same as 23 fourths. 3 and 2/3 is the same as 11 thirds. They're just written differently so that we can perform our math operations at this point. Now this is an addition problem. What we need from this addition problem is for the two fractions that have common denominators, matching denominators, or the same denominators, however you want to say it. It's the same thing, okay? So I'm just going to apply the method that we've already seen already. So I'm going to take our first denominator, 4, and I'm going to multiply it by 11 and 3. So I'm scaling the second fraction by 4 here. In the numerator, I have 11 times 4, which is 44. In the denominator, I got 3 times 4, which is 12. Now, if I do this correctly, I should, since I already see this denominator of 12, I should know right now that I should expect a denominator here of 12 as well. So that's what I'm going to do. I'm going to force it to be 12 by taking our denominator 4 and multiplying it by the other denominator 3. But if I do it there in the bottom, I got to do it there in the top as well. So that ends up being 3 times 23, 2. Well, what does that give us for a denominator? Yeah, for 3 times 4, yeah, it's 12. So see, this already shows that they match, which is going to allow me to add the numerators once I figure out the second one. And I don't have my 23 multiplication tables down, so I'm going to have to multiply these. 23 times 3. 3 times 3 is 9. 3 times 2 is 6. And I end up with 69 twelfths plus 44 twelfths. And since the denominators match, I can move on to the next step, which I think, at least last time when I saw, most of you were kind of skipping this step. Be careful if you do that because it seemed like it was causing some problems. And even for the last class that did the homework, it was causing some problems because if you skip this step, then you may get your addition or subtraction mixed up with either multiplication or division. But once those denominators are the same, I keep it the same because I'm not changing the sizes of the pieces. I'm just going to add how many pieces there are. That's from the two numerators. I'm going to take the 69 and add the 44 numerator right there. So again, this does not change the denominator. The sizes of the pieces are still in twelfths. I'm just going to need to add those two numbers. So I'm going to take my 69 and 44, and I will go ahead and add those together. Okay. So in the ones place value, 9 plus 4 is 13, carry the 1. In the tens place value, 1 plus 6 is 7, plus 4 is 11. So I end up with 113 twelfths. And then, of course, you should always check to see if our final answer here can be simplified, because if it can, then you should. Right here, I see at least 12 is divisible by 1, 2, 3, 4, 6, and 12. But 113 is not divisible by any of those, which means that this is already fully simplified. And please resist the temptation to change this into a mixed number because, like I said, sometimes elementary teachers will tell you that it's not simplified until it is a mixed number. But now that we're in a pure math setting, we do not want that to be a mixed number. Just keep it as the improper fraction. Plus, it takes away the need for long division here to change it into a mixed number. So it removes the ability to make those two mistakes right there, as long as you'll just keep it as an improper fraction. So you can see everything that we've done with addition stays the same. The only difference is in the beginning, we have to change these mixed numbers into improper.